Okay, let's continue in this hour, finishing the discussion about supernodes. Supernodes can be more complex, so rather than just a single voltage source, maybe it can include multiple sources, multiple independent sources. So first of all, is to the step is to identify all the nodes, and then we select a reference and label nodes. Usually, reference is where the node where it gets many branches, where it has many branches. So in this case, then this one, it has 1, 2, 3, 4 branches. And then we choose it as a reference. And we label this one V1, V2 at this as the second node, V3 here having voltage 3, then V4 here between R5 and R6, then V5 in the middle here. So nodes connected to reference through a voltage source. So here we have this one, P1, which is connected by a voltage source, independent voltage source. Then we identify the voltage sources in between the nodes and the possible supernode. So here could be a possible supernode, yeah, because this V4, between V4 and V5, there's a voltage source, and we can put one big node on encircling this source and use the nodal analysis using that supernode. Alternatively, there is also this voltage source between V2 and V5. Okay? Or otherwise, we can include instead this both, yeah, V2, V5, and V4 into a single larger supernode. So we can do then KCL at V3, Kirchhoff current law at V3, KCL at this supernode, this brown supernode, and the two constraint equations is given by this voltage source and this voltage source, and this one known node. So this one known V1 basically equals to the value of this voltage source. Then using Kirchhoff current law at V3, then we obtain V3 minus V2, yeah, because here the value here is V2, divided by R4, current out, yeah, then plus V3 minus V4, V4 is here, divided by R5, plus V3 minus 0, yeah, the reference voltage, divided by R7 equals to 0. KCL at the supernode, here there's a cautionary statement here to be careful not to omit any current. So V2 minus V1 divided by R1, so this current. Okay. So first is this current, yeah, V2 minus V1 divided by R1. Then this current is V5. Sorry, this current is V5 minus V1 divided by R2. Okay, yeah, this one. Okay, so we better draw with different color. So here, this is V2 minus V1 divided by R1. Then afterwards is V5 minus 0. Is it the same color? Similar. So V5 minus 0 divided by R3. Afterwards, then we have this current here, V4 divided by V4 minus 0, yeah, divided by R6. Then we have further V4, this current, yeah, from the supernode towards the V3, yeah, V4 minus V3 divided by R5. Then finally, the last one is this one. V2 minus V3 divided by R4. All the sum should be equal to 0. Okay. So after that, yeah, this is the similar current that I have just drawn. Then we also write down the voltage source, the constraint. So the constraint here is defined by the known voltage source. P1 is equal to this one, the voltage source of voltage source 1. So this is Vs1. This is Vs1. Then V2 minus V5. Here V5 is here. This is Vs2. So this is Vs2. And here is V5 minus V4 equals to Vs3. Okay, that is the constraint into the voltage source. Then, so it means we have how many equations? This one equation, second equation, third, 4, and 5. And we have 5 unknown, V1, V2, V3, V4, and V5. So with this, then we can we can solve this equation using linear algebra. Okay. Circuit with dependent sources present no significant additional complexity. So the dependent sources are treated as regular sources. Yeah? So, but then you put additional constraint equation to explain the connection of the value in that dependent sources with the value of other electrical parameter within that circuit. So similar like the previous examples. You must add one equation for each of the controlling variable. An example here, we have one independent source is 3 volt, and we have one dependent source, the current controlled current source, 2 Ix, and Ix here is the current that flows through the 6 kilo ohm resistor here. Find IO. So IO, find the current that is flowing through the 3 kilo ohm with the direction to the right. Yes, so from V1 to V2. Okay, so be careful with the direction later. So voltage source connected to the reference here is this one. So V1 equals to 3 volt. And writing KCL at this V2 node. Yeah. And so V2 minus V1 divided by 3K plus V2 minus 0 divided by 6K. Then here, since this is current is entering the node, so it means the sign will be negative. Negative 2 Ix equals to 0. Then you have to express Ix in terms of the other parameter within the circuit. So Ix here is current flowing through the 6 kilo ohm resistor. So using Ohm's law, then we can express Ix equals to V2 divided by 6K. So we have 3 equations. We have how many unknown? Also 3 unknown, V1, V2, and Ix, right? So this is a solvable, mathematically, this is a solvable equation, solvable system of equations. So we replace the Ix here using this controlling variable, then V2 minus V1 divided by 3K plus V2 divided by 6K minus 2, V2 divided by 6K equals to 0. Then you multiply all terms with 6K. So this becomes minus V2, this becomes 2 V2 minus 2 V1, okay? So 2 V2 plus V2 equals 3 V2 minus 2 2 V2 plus 1 V2 is 3 V2 minus 2 V2 equals to V2, single V2, then minus 2 V1 equals to 0. So here then we obtain, since V1 is known here, V1 equals to 3 volt, V1 is inserted here, and we obtain V2 equals to 6 volt. Having calculated V2, then we can easily calculate Ix, right? Ix is, well, we can easily immediately, because the parameter being asked is IO, and our IO is from V1 to V2. So IO equals to V1 minus V2 divided by 3K. 3 volt minus 6 volt minus divided by 3. So minus 3 minus 6 is minus 3 volt divided by 3 kilo ohm. So the result is minus 1 milliampere. Minus 1 milliampere. Okay. Another example, supernode with dependent source. So we have here one independent source, 6-volt connected to the reference. We have one voltage controlled voltage source, VCVS, here 2Vx here, and Vx here is the voltage across this 6 kilo ohms. Basically, this Vx equals to V2, right? Because it is connected to the reference. So we have here V3 equals to 6 volt. We express this first equation, and we can we have here a voltage source, a supernode. We have here a supernode. We make a supernode here. So V1 minus the constraint variable, constraint equation is V1 minus V2 equals to 2Vx, expressing the condition within that supernode. Then the controlling variable in terms of the node will be Vx equals to V2, right? As I mentioned earlier. And while V1 equals to 3 volt. Then we write the KCL equation at the supernode. Okay, here. So V1, current flowing through the 6 kilo ohm is V1 minus V3 divided by 6K. Current flowing through this 12 kilo ohm resistor is V1 minus 0 divided by 12K. Then current flowing through this 6 kilo ohm is Vx or V2 basically divided by 6K. Plus then current flowing through the 12 kilo ohm is V2 minus V3 divided by 12K equals to 0. So multiplied all each terms with 12K. So you have then 2 times V1 minus V3, and you insert immediately this V3 equals to 6 volt into the equation. So becomes 2 multiplied by inside parenthesis V1 minus 6 plus V1 divided V1 plus V2, 2 V2, then plus V2 minus V3 or V2 minus 6. So from here we obtain this equation 3V1 plus 3V2 equals to 18 volt. Yeah, and which means that if we put this constraint equation of the controlling variable, which is Vx equals to V2, and V1 minus V2 equals to 2Vx here. Okay, 2V2. So V1 equals to 3V2. Yeah, we insert it here. So 3V1 plus 6 V1 plus 1 V1. Yeah, so 4 V1 equals to 18 volt. So then we obtain V1 value 18 divided by 4 or 4.5 volt. Then IO, the question is what is IO? So will be V1 divided by 12K, 4.5 or 9 over 2 divided by 12 equals to 3 over 8 milliampere. Okay, so that is the theory. Express, write down the equation of the known independent source here. Then develop the supernode. Then write also the constraint equation describing that supernode, if any. In this case, V1 minus V2 negative 2Vx. In the previous case, it is independent source known. So we write it down in terms of the known independent voltage source inside that supernode. Then we write down the KCL at that supernode. And using the constraint equation and the known voltage source, then we can calculate, we can further calculate the KCL. Another example, we have current controlled voltage source here. So the voltage source value here is dependent on the current Ix. Ix is the current flowing through this 2 kilo ohm resistor. So it means Ix by Ohm's law, the constraint equation here is Ix equals to V1 divided by 2 kilo ohm, right? Using Ohm's law. Okay, so this is we make as a supernode, and the constraint inside the supernode will be V2 minus V1 equals to 2000 Ix, right? So first constraints due to the source is known here. Here V2 minus V1, yeah, the constraint equation of this supernode. V2 minus V1 equals to 2K to 2000 Ix. Then current controlling variable in terms of the node Ix itself is V1 divided by 2K, 2 kilo ohm. And yes, any question? Okay, I continue. V1, since here, then we can insert this value basically into this equation. So V1 equals to here V1 equals to 2K Ix. So it means when we can replace this 2K Ix equals to V1, so V2 equals to 2 V1 here. So inserting this value of Ix into the first equation, we obtain this equation V2 equals to 2 times V1. Then we write down the KCL equation at the supernode. And the supernode, the current flowing through here is, since the current is flowing into the supernode, so we assign negative value, minus 4 milliampere. Current flowing out to the 2 kilo ohm is Ix, or basically V1 minus 0 divided by 2K. Then current flowing through this is basically equals to this current source, 2 milliampere. Then plus current flowing to the 2 kilo ohm resistor, or V2 minus 0 divided by 2K equal to 0. So from here, we obtain multiplying with 2K, each term with 2K, then we obtain V1 plus V2 equals to 4 volt. Yeah, and then since we obtain minus 2 V1 also, plus V2 equals to 0. Yeah, this is divided by 2. And add, so we obtain 3 V2. Basically here we use this formula V2 equals to 2 V1 into this equation. We obtain 3 V2 equals to 8 volt. Okay. So we obtain the value of V2. Since we obtain the value of V2, then we can immediately calculate IO here. IO here with current flowing through the 2 kilo ohm using Ohm's law can be calculated as V2 divided by 2K. Yeah, or here 8 divided by 3 divided by 2K, so equals to 4 over 3 milliampere. Okay, now another example with dependent sources. So we have one independent voltage source here with one current controlled voltage source, yeah, a voltage source whose value depends on the Ix, and Ix here is the current flowing through the 2 kilo ohm resistor. Okay. The question is, what is the V out? Yeah, I think here. So identify and label the nodes. This is V1. So this is Vx. This is V2. Two nodes are connected to the reference through the voltage source. V1 is connected through this Vs. V2 is connected through this dependent voltage source. So V1 equals to Vs. V2 equals to 1000 A Ix. So A here is an conversion factor having a unit of volt per ampere. Then writing KCL at Vx, we obtain Vx minus Vs, yeah, or minus V1 basically, but since V1 equals to Vs, immediately we write down Vx minus Vx minus Vs divided by 2K plus Vx minus 0 divided by 2K here, and then Vx minus V2 divided by 3K equals to 0. Okay, this currents. Then expressing the control variable in terms of the node voltages, Ix equals to this one, Ex divided by 2K. Yeah. Then replacing Ix here in V2, where is V2? Yeah, here. So we replace Ix here with Vx divided by 2K. So V2 then equals to 1000 or 1K multiplied by A, then by Vx, by Ix, Vx divided by 2K here. So from here we obtain V2 equals to, so K cancel each other, A Vx divided by 2. Yeah, the voltage 2 here. A times the Vx divided by 2. Then replacing V2 in this KCL, yeah, by this value. So then we obtain an equation which contains Vx and Vs. 3 Vx minus Vs, and then multiplying with 3k, yeah, with 3k. 3 Vx minus Vx plus 3 Vx here, plus 2 Vx minus a Vx, yeah, replacing V2 with this one, minus a Vx divided by 2 equals to 0. And then we obtain 8 minus a times Vx equals to 3 Vs. So when a equals to 8, then what happens? Well, actually Vs should be there. Yeah? So when a equals to 8 means that the Vs will be 0. So the value is what imbalance between the value here Vx and this Vs. Another example of application of supernode with dependent sources. So here we are asked to find the voltage at this 1 kilo ohm, voltage across this 1 kilo ohm resistor V out. Okay, so it has 3 independent sources, 2 independent current sources, 2 milliampere, and 1 independent voltage source, 4 volt, and then 1 voltage controlled voltage source. Yeah, 2 Vx, and Vx is defined as the voltage across this 1 kilo ohm resistor. So we can draw the supernode here at the dependent source. Yeah, after we label this node as V1, we label this as V2. So basically V2 equals to Vx here, and so this is 2 milliampere is basically 2 divided by 1000. Yeah, this 2 divided by k equals to 2 divided by 1000, or 2 milli. Yeah, 2 milliampere. Different way. Okay, and then this node we assign as V4, this node we assign as V3. So at V4, this one, V4, since this is connected, this voltage source is connected to the reference voltage, then V4 equals to this value. Yeah, V4 equals to 4 volt. Then at this supernode, V1 minus V2, the current flowing, this is the constraint equation inside the supernode. V1 minus V2 equals to 2 Vx. Then writing the equation at the supernode, here, since the current is entering into the supernode, so we assign negative value, negative 2 milliampere, plus the current, this current, yeah, which is Vx basically divided by 1 kilo ohm, or V2 divided by 1 kilo ohm. Yeah. Then the current flowing through this another 1 kilo ohm resistor here towards V3 node. So V2 minus V3 divided by 1K, plus this current flowing through the 1 kilo ohm resistor, V1 minus V3 divided by 1 kilo ohm. Then plus this another current flowing into the V4 node, V1 minus V4 divided by 1K equals to 0. Or we can immediately replace V4 with using the this first equation. V4 equals to 4 volt. So this one immediately we write it down as V1 minus 4 volt divided by 1K. Okay, then we have another node here at V3. So negative 2 milliampere going here, yeah, because the current is entering into the node V3, negative 2 milliampere, plus V3 minus V2 divided by 1K, plus V3 minus V1 here. This is V1 node basically. So this is a single node basically, because it is connected. So this is the value is V1. Okay, so V3 minus V1 divided by 1K equals to 0. So the controlling variable Vx equals to V2 here. The controlling variable here Vx is defined as the same as V2. Then solving the equations, the two equation multiplying with 1k. Here we can replace Vx equals to V2 into this one. Yeah, so Vx equals to V2 here. So then this one, then we obtain V1 minus V2 equals to 2V2. So V1 equals to 3V2, right? So this one we can further insert into this equation, and this equation, the value of V1 is replaced with the value of V2. Okay. Then eventually we obtain with this one, V1 equals to 3Vx, or 3V2, basically the same, V2 equals to Vx here. So V1 equals to 3Vx. Then from this equation we obtain 2V1 plus 2Vx minus V3 equals to 6 volt. And from this equation we obtain minus V1 minus Vx plus 2V3 equals to 2 volt. So how many unknowns we have? We have 3 unknowns, V1, Vx, and V3. And we have 3 equations. So this one is solvable. You can rewrite this into a matrix, and you can immediately insert into Octave or MATLAB. Alternatively, you can also manually calculate. Yeah, so if you replace V1 here using Vx, okay, so you then V1 here also with Vx, then you have 2 equations with 2 unknowns, V3 and Vx. From there, you can calculate either Vx or V3. Yeah. But the variable of interest is Vout, yeah, Vo, which is here defined as V1 minus V3. So from there, okay, let me delete first. Okay, this is another example. So basically, but from here, this is not calculated until the end, but I hope all of you already understand that based on this is solvable. Yes. 3 equations for 3 unknowns, which can be even further simplified into 2 equations with 2 unknowns, V1 and V3. This is another example. I'm not sure if it is the last. So we have 2 independent source, yeah, V12 volt and 6 volt, and we have 2 dependent sources. One is voltage control voltage source here, 2Vx, and the other one is current control current source, 2Ix. Ix is here. Then Vx is defined as the voltage across this 1 kilo ohm resistor. And the question is we are asked to find this IO, the current flowing through this 1 kilo ohm resistor. So then we can define the nodes and supernodes. The supernodes we can define here, for example, yeah, in this independent current source. Here, since it is connected to the reference, then no need. So we immediately, this is V2 equals to 12 volt. So at V2 equals to 12 volt. At this V3, V3 is also equal to this dependent voltage source, yeah, equals to 2Vx. Okay. Then using the supernode here, then we can calculate that is being cut. V4 minus V1, this is the constraint equation. V4 minus V1 equals to 6 volt, yeah, because this V4 is drawn here as having higher potential compared to the V1 on the top. So V4 minus V1 equals to 6 volt. Then the KCL equation will be here. This one is V1. V1 minus V2 divided by 1K here. This current. Okay, this current. Okay, this current. Yeah, this current the same. V1 minus V2 divided by 1K. Then V1 minus V3, so this current divided by 1K. Then afterwards is 2Ix. 2Ix is here. this part, plus 2ix. Then we have this current also. The current flowing here is P4 divided for P4 minus P3. Sorry, this current first. P4 minus P3 divided by 1K. 1. And then P4 minus P5, this one, divided by 1K. And finally, the last one is this current. P4 minus 0 divided by 1K. This one. Okay. So then we also write down the KCL at P5. KCL at P5 is negative 2ix plus P5 minus P4 here, this current, divided by 1K plus P5 minus 0 divided by 1K. The controlling variable is this part, Px equals to P1 minus P2, and Ix here equals to P4 divided by 1K. So we have how many? Equation 1, 2, 3, 4, 5, 6, 7. We have 7 equations and 7 variables, P1, P2, P3, P4, P5, Px, and Ix. It's 7 unknown variables. But this is solvable, yeah? As long as the number of the equations equals the number of the unknown, or even the number of equations is more than the number of unknowns, then from mathematics, we know that it can be solved. Here, finally, what we want to calculate is actually the IO, the V5 divided by this 1K. Okay, so this marks the end of node analysis, yeah, node analysis using Kirchhoff current law. So let's have a break. And in the second hour later, we will